Today, we are also going to focus on graphing radical functions, and specifically, we're going to focus on graphing square root functions. In graphing square root functions, we have to be able to identify the domain and range, and we have to be able to identify any transformations that we see. So the first thing I want to look at is our equation, okay? And our equation is y is equal to a times the square root of x plus or minus h plus or minus k. And this should be coming back to you that we have seen this a, this h, and this k before when we talked about transformations with quadratic functions, the first unit. So how is that going to help us identify the domain and range? So the key thing we want to talk about here is that h and k still stand for our vertex. And remember, h is always opposite of what's given in the equation. Now we'll go back to this in regards to transformations, but what does that vertex value mean when it comes to square root functions? Well, the vertex value tells us right away the starting point of our graph. Which is very much needed when identifying the domain and range. The other important part of this is the a value. And the a value, okay, once again tells us the direction of our graph. So if it's positive, it's going to look like this. If it's negative, it's going to look like this. So if it's positive, it's pointing up. If it's negative, it's pointing down. And this starting point is our vertex, our HK value. So this tells us a lot about our expected domain and range. Well, how? Okay. Our domain will always be the radicand greater than or equal to 0, okay? And then you will solve for x. All right? So you will always set your radicand greater than or equal to 0 and solve for x. And that's because that will prevent us from getting any imaginary numbers. Now, our range is a little bit different. Our range is either going to be y is greater than or equal to the k value of our vertex, or y is less than or equal to the k value of our vertex. It'll be greater than if our graph is pointing up. It will be less than if our graph is pointing down. Now, what tells us this? Our a value. If our a value is positive, we know our range is going to be y is greater than or equal to k. If it's pointing down, that's a result of our a value being negative, we know that our range is going to be y is less than or equal to k. So let's look at this with our first example. Let's say I asked you to identify the domain and range of y equals 1/2 times the square root of x minus 3 plus 1. So the first thing you're always going to do is you're going to identify your vertex, your HK value. And in this case, it's going to be 3, 1. Remember, we're comparing it to y is equal to a times the square root of x plus or minus h plus or minus k. And remember, the h value is always opposite of what's given to us in the equation. Now in this case, we can identify our a value is 1/2, which is positive, which means it's pointing up. Okay? So let's see how we're going to use that information to find our domain and range. So to find our domain, we're going to set our radicand greater than or equal to 0. Our radicand is the entire term underneath the radical sign. So that's x minus 3, which means that x is greater than or equal to positive 3. Now, we no longer write this in this form. We write it in interval notation. So we're going to say it's going to be 3 to positive infinity. Okay? When it comes to our range, okay, we have to decide whether it's y is greater than or y is less than or equal to the k value of our vertex. Well, the k value of our vertex is 1. And we know because it's pointing up, its y is greater than or equal. So we're going to convert it into interval notation from 1 to positive infinity. Okay? I'd like you to do the next one on your own. I'd like you to identify the domain and range of y equals -3 times the square root of x plus 4 minus 7. In order to do this, the first thing we're going to have to do is identify the vertex. Remember, the vertex is the hk value, and h is always opposite of what's given to us in the equation. So our vertex will be -4, -7. Okay, we're also going to identify our a value, which is -3, which means our graph is pointing down. So now that takes us to the domain. To find the domain, we are going to set the radicand, which is x plus 4 greater than or equal to 0, to ensure that we get no imaginary numbers, and we get x is greater than or equal to -4. We're going to write that in interval notation as -4 to positive infinity. To find our range, okay, we have to identify, is y greater than or equal to the k value, or is y less than or equal to the k value? Well, we know it's less than or equal to our k value because we said our graph is pointing down. So our answer will be -infinity to -7. Excellent. So the next thing we're going to talk about is how identifying the domain and range is going to help us when we graph square root functions. So we're going to follow a very similar pattern. The first thing you're going to do is you're going to definitely want to identify the vertex. Then you're going to want to identify the domain and range, because the domain is going to tell us what to do in step 3 here, which is to plug in 2 additional x values into an xy data table to graph 2 more points. So let's look at our first example together. Okay? Our first example is I want you to graph y equals 2 times the square root of x minus 3 plus 1. So the first thing we're going to do is we're going to identify the vertex. And our vertex here is going to be 3, 1. And we're going to be able to graph that because we know that that is our starting point of our graph. Okay? Then the next thing we're going to do is we are going to identify the domain and range. So we know what the domain, we're going to set our radicand greater than or equal to 0, and we get x is greater than or equal to 3. So our domain is from 3 to positive infinity. And then to find our range, all right, we know our a value is 2, which is positive, which means that we know our graph is going to point up. So as a result of that, we know that our range is going to be y is greater than or equal to the k value of our vertex. Y is greater than or equal to 1, which is 1 to positive infinity. So now that we've identified all of that, we need to create an XY data table. And the X values that you're going to plug in have to fall within the domain. So our domain is 3 to positive infinity. So we need to plug in X values that are greater than 3. We already know 3, 1 because that's our vertex, but we need to plug in X values greater than 3. So the first X value I think of is 4. And when I plug in 4 for X, I get 2 times the square root of 4 minus 3 plus 1. So 2 times the square root of 1 plus 1. The square root of 1 is 1, so we get 2 plus 1. So our point is 4, 3. So we're going to draw that point, 4, 3. Okay? Now, the last thing we need to do is pick another point. Now, if I plugged the point 5 in, I wouldn't get a perfect radical. I'd get the square root of 2. I don't know what that is, and I don't have a calculator. If I plugged in 6, I'd get the square root of 3. Don't know what that is. But if I plugged in 7, I would get what? I'd get a perfect square. I'd get the square root of 4. So that's 2 times 2 plus 1 equals 5. So our next point on our graph is 7, 3. I'm sorry, 7, 5. So there would be our point, and that would be our graph, and we would be done. We identified the vertex, we know the domain and range, and now we've graphed it out. So I would like you to do the same thing on your own. I would like you to graph the equation y equals negative 1/2 times the square root of x plus 1 minus 3. Okay, so the first thing we're going to do, step 1, is identify the vertex. And our vertex is going to be negative 1, negative 3. The second thing we're going to do is identify the domain and range. The domain is x plus 1 is greater than or equal to 0. So x is greater than or equal to negative 1, which written in interval notation is negative 1 to positive infinity. We also need to identify the range. Well, our a value is negative 1/2, which means we know our graph is pointing down, which means that y is less than or equal to k. So in this case, y is less than or equal to negative 3, which means in interval notation, we would have negative infinity, negative 3. So the last step is identifying what x values we should plug into our data table. Well, our x values have to fall into our domain, and our domain tells us that it has to be greater than negative 1. So automatically, we would try plugging in 0, and if we plug in 0, we get a perfect square. So negative 1/2 times 0 plus 1 minus 3. So negative 1/2 times the absolute value, times the square root of 1 minus 3. So negative 1/2 times 1 minus 3, which gives us negative 3.5. So if we were to graph our vertex at negative 1, negative 3, and then our next one would be at 0, negative 3.5. So then we have to decide what the next x value should be. Our next x value we can try as 1. But if we plug in 1 for x, we get the square root of 2, not a perfect square. If we plug in 2 for x, we'll get the square root of 3, not a perfect square. If we plug in 3 for x, we get the square root of 4, and that's a perfect square. So we get negative 1/2 times the square root of 4 minus 3. So negative 1/2 times 2 minus 3. So negative 1 minus 3 yields negative 4. So we have a point at 3, negative 4. So there it is. And now we can graph our function. Excellent. All right. So now that we've identified how to find the vertex, how to find the domain and range, how to graph a radical function, let's talk about how to identify the transformations. Now, these transformations are the same we did with quadratics. So let's look at y is equal to a times the square root of x plus or minus h plus or minus k. The same transformations apply. So h represents the horizontal translation. Okay, remember that if h is positive, we shift left h units. And if h is negative, we shift right h units. All right? The second transformation is k, and this is our vertical translation. And if k is positive, we shift up k units. And if k is negative, we shift down k units. All right? The third transformation is a reflection, and that will only occur if A is negative. So the reflection across the x-axis, and that's if A is negative. And the fourth one is the vertical stretch or the vertical compression. We have a vertical stretch if the absolute value of A is greater than 1. We have a vertical compression if the absolute value of A is between 0 and 1. Okay? So let's identify those transformations from our equation. So for example, let's say we had identify the transformations of y equals negative 1/2 square root x plus 7 plus 4. Remember, this is always in comparison to the general equation y is equal to a times the square root of x plus or minus h plus or minus k. So, right away, we know we have a horizontal translation, 7 units left, because our h value in the equation is positive 7. All right, our k value is 4, so we have a vertical translation, 4 units up. Ooh, our a value is negative, so we have a reflection, across the x-axis. All right, and if we take the absolute value of a, we get 1/2, which means that we have a vertical compression by a factor of 1/2. So the same transformations we talked about with quadratic functions, we apply to radical functions. So I would like you to do the same. Identify the transformations of y equals -2 square root x minus 10 minus 11.